Let us now see an application of the Lagrange multipliers. We are told that a flat circular plate has the shape of the region x squared plus y squared is less or equal to 4. The plate, including the boundary x squared plus y squared is equal to 4, is heated so that the temperature at any point x comma y on the plate is given by the function of the temperature Tx comma y equals to x squared plus y squared minus 2x. We are asked to find the temperatures at the hottest and coldest points on the plate. That means the extreme values of the temperature on the plate, including the boundary x squared plus y squared is equal to 4. The temperature is given in degrees Celsius. First of all, let's check to find if we have any critical points. So in order to do that, we'll have to find the Tx of x comma y that is equal to 2x minus 2, and we have to set that equal to 0, which means that 2x is equal to 2, and that means that x is equal to 1. We also need to find the Ty of x comma y, which would be equal to 2y, and setting that equal to 0 will give us that y equals to 0. So from that we get only one critical point, the point 1, 0, which lies on the region x squared plus y squared is less or equal to 4. So that is a critical point of the function. Therefore, we can find the temperature at that point 1, 0, which would be equal to 1 to the square plus 0 to the square minus 2 times 1. So this is equal to 1 minus 2, and this is equal to negative 1. So the temperature at the point 1, 0 is equal to negative 1. And this is in degrees Celsius. So now that we found the critical point of the function of the temperature, let's go and see what we can do with by using the Lagrange multipliers. So we'll use the Lagrange multipliers to study the maximum and minimum of values of the function on the boundary circle g of x comma y equals to x squared plus y squared is equal to 4. So this is the constraint that we have. The boundary of the plate is actually the constraint that we have. So let us check now to see what we can do in order to find the three equations that we'll need in order to evaluate the x, y, and lambda. First of all, we have that we have the Tx and Ty that we have actually found, and we also need to find the Gx, which would be equal to 2x, and the Gy, which is equal to 2y. So setting the three equations, we have first of all that Tx is equal to lambda times Gx, and that gives us that 2x minus 2 is equal to lambda times 2 times x. And then the second equation is that Ty is equal to lambda times Gy, and that gives us Ty is equal to 2y, and this is equal to lambda times Gy, which is 2y. And then the third equation is the constraint. So we have that x squared plus y squared is equal to 4. Starting from equation 2, we have that 2y is equal to lambda times 2y. So because we don't know what happens to y, we cannot simplify here So we'll have that 2 lambda y minus 2y is equal to 0. So that gives us that lambda y minus y is equal to 0. Factoring y, will have y times lambda minus 1 is equal to 0. So that gives us two solutions, either that y equals to 0 or that lambda is equal to 1. Now, we'll have to check what happens when y equals to 0, and then we'll have to check what happens when lambda is equal to 1. For y equals to 0, we plug that in equation 3. So from equation 3, we'll have that x squared plus 0 squared is equal to 4. So that gives us that x squared is equal to 4, which means that x is equal to plus or minus 2. So from that, we get 2 points, the points 2, 0 and negative 2, 0. And let's find what is the temperature at those 2 points. So the temperature at 2, 0 is equal, now we have 2 to the square minus, and then plus, 0 to the square, and then minus 2 times 2. So that will give us 0 degrees Celsius. So the temperature at the point 2, 0 is equal to 0 degrees Celsius. And also, the temperature at the point negative 2, 0 will be equal to negative 2 to the square plus 0 to the square minus 2 times negative 2. So that will give us 4 plus 4, which is equal to 8 degrees Celsius. So the temperature at the point negative 2, 0 is equal to 8 degrees Celsius. Now let's, so we checked what happens with y equals to 0. Now let's see what happens when L equals to 1. The second root that we have found. So for L equals to 1, substituting that to equation 1, we'll get that 2x minus 2 is equal to 2x. So that gives us that if we simplify, we have 2x minus 2, minus 2x, minus 2 is equal to 0. So that gives us that negative 2 is equal to 0, which is impossible. So we don't have any value and any point that is given for L for lambda equals to 1. Now, so we have only know 3 points. The first point that we had was the critical point, where we had that the temperature at the point 1, 0 was equal to negative 1 degree Celsius. And then we had also that the temperature at 2, 0 is equal to 0 degrees Celsius, and the temperature at the point negative 2, 0 is equal to 8 degrees Celsius. So from these 3 temperatures, we see that the minimum temperature is the temperature at the point 1, 0. So this is the minimum temperature. Which corresponds to the coldest point on the plate. And then from the other two, the maximum temperature is the 8 degrees Celsius. So this is the maximum temperature. which corresponds to the hottest point on the plate. So the coldest point on the plate is the point 10, where the temperature is equal to -1 degree Celsius, and the hottest point on the plate is the point -20, where the temperature is 8 degrees Celsius. So this is the minimum temperature, the coldest point on the plate, and with the lowest temperature value, and the T of -2,0 equals to 8 degrees Celsius is the maximum temperature, so that corresponds to the hottest point on the plate.